if you're in the client underneath LSR, there's IETF 116, 17, 18, and 119 is where everybody is showing up now. So they're in the 119 topic.
What time is it? It's 11 o'clock, I guess. I mean, it's, 1 o'clock.
Let's get started.
Yeah.
Hello, everyone. Welcome to the LSR session. I'm Yingzhen Xu. So we have Chris and AC online with us. So you guys probably want to say hi.
Hi.
And so we'll start from the working group status. AC will do the status working group update.
Okay. You've all seen the note well by now, and you know that if you know about any IPR, you have to declare it, and you know you have to behave when you're at the IETF. I guess you can read it, but by this time everybody should know this. You see all the relevant best current practice documents. I'm going to just say, should we thank John for the work he's done as our AD over the last 4 years now?
Of course, yeah.
Thanks, John.
You're welcome.
Yeah, and you're coming on a clean queue. You're going to see what in the status. You'll see what's coming though. The good thing is with Gunther, he's been a draft offer. A document offer in LSR. So he's not coming into your cold for many, on a lot of the documents, and he should be able to step right in because he's familiar with both the IGPs. Did you want to say anything, John?
I just wanted to say, thank all of you. It really has been one of my favorite groups, and I'm sorry to give it up, but yeah, Gunter's could be great.
Okay, I'll just go right into the status. It won't take too long. IGP Flex algorithm and IP networks. We have the original Flex algorithm was coupled to SR because it works, it worked pretty nicely if you have different SIDs per algorithm, but this draft extends it so you can do it without SR. And also, this is a long time coming, the OSPF v3 extensions for segment routing. It made it to the through the ISG and is published now. We got the OSPF v3 extended LSA Yang model. We need this for almost any extensions to OSPF v3, any of the other ones. So it's good that this is done now, and we can go on with the SR documents, Yang models, now that we have this. And area proxy, I don't know if you know this. This is also on the RFCQ. I don't know if you were in the routing working group, but this draft is leveraged in Tony Lee's proposal for a satellite routing architecture. Okay, these are through, John cleaned these both out. Got through his comments, and the offers got through, and these are going to be going to telechat soon. Both the fast flooding document and dynamic flooding in dense graphs. That's sparse flooding. Okay. Didn't we have? Let's see. These ones are adopted. Shoot. I'm missing one. Okay. Sorry. These are the documents we've recently adopted as working group documents. We have the prefix flag extensions for OSPF and OSPF v3. We had this in ISIS. This is just kind of consolidated maintenance draft. We're going to have an update today on multi-part TLVs. That was a draft adopted as a working group document, and the longstanding advertising unreachable links was adopted, and we started the adoption call just this week on a maintenance draft for also another maintenance draft for OSPF v2, get it in line with OSPF v3 and ISIS for attaching the Anycast property to prefixes. Okay. The reason you saw me miss a beat there is because I thought this was coming before the adoption ones. Anyway, we finished the working group last call on this informational draft on how to do network slicing with multi-topology, but it has a few normative references that we're going to wait for before we send it for publication. You see the two drafts there. Also, we had a working group last call. I had a Shepherd's review, and that was the authors just satisfied my comments this week. And there were, I won't say a lot of updates, but there were a few updates based on my comments. And I'm going to leave the working group last call open for a little while in case try and get some more reviewers. Especially if you're familiar with Flex algorithm, I'd encourage you to take a look at this one because it adds some new constraints that can be used for bandwidth, that can be used for Flex algorithms. Gunther, this will probably be the first one that we send to you for review before you send it. You do the working group the IETF wide working group last call. And we did these two drafts. These are the two SR Yang models. Actually, I should say they're the SR MPLS Yang models. And we've done both the Yang doctor reviews on both of these. And I think we also did the route. I seem to remember we got the routing directorate reviews done for these two. So we're going to do working group last call of these shortly after the IETF. These will be the next ones we do. Now, the interesting thing about these are the last two documents that are working group documents that were working group documents before we merged the ISIS and OSPF working groups into the LSR working group. So once we get these through the process, one can just search for -LSR-, and you'll be able to find all the working group documents or all the documents for the working group. And we have a few others. We think this one is ready. The ISIS currently supports multiple tags for prefixes and tags for all kinds of routes. This extends that to OSPF and OSPF v3. Here's another Flex algorithm one. This is a rather simple one when you compare it to the one that we just finished the bandwidth. We'd like to working group last call this one as well. It's been around for quite a while. And I'm not going to say too much more about that. If you think your document is ready for working group last call, like I would say, take it to the list. A lot of times it seems like we'll come away from it and we're going to say, okay, we're going to do a last call or an adoption call, and then the offers, as offers, you should prompt us if we don't do it. if we said we were going to do it, or you should, if you really think it's ready, we don't mind getting email asking for it to be done. And I think that's, yeah, we got, okay, yeah, this was one we just recently adopted since the last IETF. And that's it.
Any questions? If not, we go to the next presentation.
Oh, I just wanted to say one more thing. I'm in the Hedgehog, and I don't know who else is. I'm going to be taking some notes, but if anybody wants to help out as well, that's the note taking. Please do so. Thanks.
Okay, Yingson, are you gonna control the slides?
No.
Or
you
whoever
have the
is.
control.
I have the control.
Yeah.
Okay, I guess I do. All right, so this is an update on multi-part TLVs in ISIS on behalf of my co-authors. This is just the overall motivation for the draft. This slide has been presented before. I'll go through it pretty quickly. It's well known that the ISIS TLV is limited to 255 octets. There are new technologies such as segment routing, flex algo, traffic engineering, increased usage that are forcing us to advertise more than 255 bytes of information about certain objects, particularly neighbors and prefixes. The solution that has been used and specified for a number of other TLVs in the past has been multi-part TLVs. So we are extending the use of multi-part to other TLVs where it has not been explicitly specified in the relevant RFCs. There are already implementations that are using this for neighbor and prefix TLVs. And we've learned, of course, that partial deployment is very problematic. So the other motivation for this draft is, to make sure that everybody understands this is the solution of choice. The draft was first published in January of 2022. Got a lot of lively discussion over the almost 2 years, and it was finally adopted in December. Since December, we published one update with a couple of minor changes. So the changes that we put in, we have examples in there of how to use a key to identify that two different TLVs are actually talking about the same object. And we simplified the examples of the key because this draft is not intended to document in great detail the encoding for any particular TLV. That's the responsibility of the relevant RFC. So we took out some details that we thought were not generic. The other change we made, there was an ask from the operator side, particularly from Bruno, who unfortunately doesn't seem to be in attendance. He wanted us to put some must statements in about how implementations provide controls to prevent or deal with partial deployment for a particular TLV. We were reluctant to do this. We think this is not appropriate for an IETF standard to document, to mandate a must behavior for what's essentially local configuration options. But his point is well taken because partial deployment, particularly of TLVs that are so widely used as neighbor and prefixes, is very problematic. So we added a paragraph to try to emphasize the importance of an implementation providing these controls. All right, next steps. We the authors have no plans for any further changes. So we think this is ready for working group last call. And we'd like to emphasize there is a need. There are deployments today where this functionality is required, and there are multiple existing interoperable implementations. So we think this is ready. That's it.
Okay,
Yeah.
we'll look at this. We probably could put it ahead of a few of the others. I'd like to get those, like I said, I'd like to get those 2 Yang models because they're so old. Working group last call, but in IETF terms, the time it takes, if we're direct about it, would only take a few weeks for each, so it should be all right.
Well, we all know Gunter's very, very fast, right?
We could also the Yangs don't really overlap technology wise either, right? So we might be able to run them together.
Yes,
The only reason not to run things together is you don't want people to miss them.
Okay, if no more question, we go to the next presentation. So I will do this one. I'm going to do an update of this ISS module. This one was done because of the multi-part.
Ying Zhen, it doesn't sound like your mic is on.
How about now?
It's better.
Okay. Guess I have to stay really close to the mic. Okay, I'll try. This is the PIX-YANG module was done as part of the multi-part of TLV work. That's the motivation for doing this. And later we realized we could use this to do more work for service providers. It can be used to query a router's implementation status of all the protocol, different RFCs. So this one was already presented at last IETF. And not working. So there was no, people were okay with the proposal. The biggest argument is whether we should call the PIX name is okay or we should give it a new name. So there was some discussions for brainstorming, and here are some options. But so far, I haven't figured out which one, I don't think any of those can beat the protocol implementation conformance statement, the original one. I think, don't think about the original ISO definition. Just think we are borrowing a name. If you have better suggestions or you really into any of these names, please speak up. Okay, so one thing we did do is to split the draft into two. So now we really have one for the framework. That's the general query. And the one draft just for, we use segment routing for MPRS as an example to see what we can do with this model. So this, like a refresh of your memory why we are trying to do this. We have the draft LSR ASS picks. That's the foundation of all these features that's used to query the pick status. And we also have an IANA module that maintains all the features definition.
They're saying that your mic is not turned on. Is that, you check? Yeah.
I'll just stop there. It's not working?
The people are complaining online.
How about this mic? This one is working, right? But
Yeah,
But
can
we
you do it? Can you do it from there?
yeah, I can do it from there, but we need the presenter's mic to be working anyway.
Yeah.
Yeah. Okay. So this one shows the slide shows the detail of this module, and we didn't change much from last IETF. So you guys are welcome to take a look and see whether this can meet your requirement. And so basically, this is the IANA module. Every time we add a new feature module, we will add one identity. That's maintained by IANA module. And then the framework to query the feature, we don't need to change that. This can just stay there. Yeah, the mic is not really working. Maybe too low, the volume set too low. I'll try to talk here. How about now? Can online people hear me from this mic?
It's a little better.
A little better?
Yeah, it's better than it was. It's not so soft.
It's not as loud as that one.
Yeah, it's okay now as long as you can you take it off the holder and like a
How
rock
about
star?
now? I speak very, very close. Cannot be closer.
No, it's really loud now.
Otherwise, it's gonna be in my mouth. Okay. I'll try to talk loud here. And so this one is a detail of the segment routing MPRS module. And we didn't change this one. It's the same as last one. So it's put here for your information. But we did split it as a separate document. So later, any new feature, new RFC follows the same thing as this document. You can just sort of set up as an example. You have a new RFC, you just look at what we've done in this module, follow the same style. Of course, the technical detail, exactly how much detail you define in your module is up to you. It's mouse trouble. And that's it. So the module is done for service providers. So this time we did get China Telecom to say they want this, and we will have a new author, Yongqing Zhu. I will add him in the next version of the draft. But we do, if you are a service provider, please tell us whether this is useful for you. And since right now we are really at the early stage of this document, we will need to add more features in as well, doing this for OSPF as well, maybe BGP later. It's really to query protocol status. Okay. Any questions? If not, go to the next one. And of course, we'd like to request adoption of this draft.
I'm just gonna say, I think this is a good idea. I think we're gonna learn from this, and on what the right thing to put in this is, and we're not gonna find out unless we adopt it and start trying to use it. So I think we should adopt this and go forward.
Okay.
Hello, can you hear me?
Yes.
I can't control. Oh, yeah.
Okay.
Hello, everyone. Hello, everyone. This is Yuanxiang from New H3C Technology. I will present a method of source address validation in intra-domain network. In the draft LSR intra-domain architecture, it describes the intra-domain subnet architecture, which achieves accurate source address validation in an intra-domain network according to the server-specific information exchanged among routers instead of depending on local routing information. The main task of intra-domain server is to efficiently and accurately generate the correct mapping relationship between the source prefix and the valid incoming interface called server rule. Based on this architecture, we propose a solution to generate server rules in intra-domain network. This is our proposal. Step one, customer-side router advertises the source prefix participating server rule calculation through IGP. Step two, when other routers receive the protected prefix, a shortest path forwarding calculation routed at the IGP router advertising the router will be done. Based on the shortest path, determine the legal incoming interface of the protected prefix for server rule. Step 3, use the protected prefix and the calculating incoming interface server rule can be generated. This is an example of the calculation process. As shown in the figure, take R3 as an example. After R3 received the protected prefix P1 from R1, it used R1 as the root to calculate which interface the packet will arrive in R3. The result is that the packet will from P1 will arrive from interface 1. Therefore, interface 1 is the legal incoming interface of prefix P1. Use the same method. R3 can calculate the legal incoming interface for prefix P2, P4, and P5. This is a problem of incalculated server information calculation in the inter-area network. As shown in the figure, R3 is in area 0 and R6 is in area 1. When advertising inter-area routers, R3 can't be aware the specific cost of the link in area 1. According to the routing information, R3 will calculate that the incoming interface of the packet from prefix P6 is interface 1. but based on the actual cost of the link, it is incorrect. The packet from P6 will reach R3 through R7 and R5. The real incoming interface is interface 2. To solve this problem, we extend the IGP to carry the total reverse cost from the router where the prefix is located to ABR in the intra-area network, as shown in the figure. When R4 advertises the prefix information of R6, it carries cost of 10 and the reverse cost of 100 at the same time. Similarly, the cost of R6 network prefix information advertised by R5 in two directions is 40 and 50 respectively. R3 then determines the real incoming interface or according to the reverse cost. To carry the reverse cost in the inter-area network, we need another extension of IGP. If within the same area, we don't need to carry the reverse cost. This is the extension of prefix subtheory. It is used to identify the protected prefix. We need extension for OSPF v2 and OSPF v3. This is another extension. Prefix reverse cost subtheory is used to carry the total reverse cost from the router where the prefix is located to ABR. The proposal has been presented at the IETF 114 meeting of sub-network group and has received positive feedback. Now we are seeking for more feedback from LSR work group. Thanks very much to AC and Les for providing feedback in the meet list before the meeting. Let me explain here about two comments. One, about advertising protected prefix. When in a network which is partial deployment of server, it's possible to identify which prefixes need to be used to generate server rules through the protected prefix. After receiving this routing information, it's up to the router to decide whether to process it based on this subtheory or whether to discard packets from unprotected prefix. Of course, once all routers in the domain support server, all prefix should be processed without the need of for specialized protected prefix. This is about one comment. About another comment, advertise whether we need to advertising reverse cost. I think it's necessary because if within the same area, it can not carry the reverse cost, but in intra-area, we need to carry the total reverse cost from the router where the prefix is located to API in the inter-area network. That's all. Any questions or comments are welcome. Thank you.
I see. I'm in the queue. I just told you. I know. For the inner area, I don't know why you want to advertise the prefixes that need to be protected by this. Why wouldn't you just do them for them all? Because it's just a reverse SPF computation using the reverse cost. So it seems like it doesn't make any sense to advertise anything inter area. And for the inter area, I think this is very fragile trying to advertise these reverse costs. Really the easiest way to do it is for the inter area ones, just to allow it from any of the ABRs for that area. That's what I think. But anyway, I mean, this is probably a longer discussion. I guess Les is in the queue next.
Yeah, I just kind of wanted to echo what AC has said, not only just now, but also on the list, that I don't think we need any protocol extensions. If anybody is concerned about identifying the prefixes that you want to perform this for, I mean, you can always use tagging to identify those prefixes, or simply use local configuration, some kind of filtering. I just don't see the need for the protocol extensions.
Any more questions? Okay, if not, thank you for the presentation. We'll go to the next one. Try the mic. Talk really loud. Hold on, let's see. No, it should be this one, I think. Try this one, see whether it works. I don't know why it's not working. I tried before the meeting. Okay, then I'll just say next slide.
Okay, hi, I'm Yao Liu from ZT, and I'm presenting signaling aggregate header size limit via IGP on behalf of my co-authors. Next, please. And the concept aggregate header limit is introduced in IFC 8883, and it is a
I didn't touch it. Okay, hold on.
okay.
Why? Something wrong here? Okay, just
Okay. So it is a total header size that a router is able to process due to its processing limit. For hardware devices designed with passing buffer, it is related with the device buffer size and buffer design. And if the limit is exceeded, the packet may be dropped or sent to the slow path. And as we know, the total packet header chain size is increasing greatly in SRv6. So for the header nodes, we have IOM data fields can be in hop by hop or destination option header. And it is similar for alternate marking. And for network slicing, you can have NIP option in hop by hop header. And for SF service programming, metadata can be carried in SHTRV. And for the intermediate nodes, there's some binding set, so a new set can be encapsulated to the original packet. And for TLFA, a repair list can be encapped by PLR. So, and we can see there are still some ongoing individual works wants to carry the data along the SRv6 packets, whether it's in the hop by hop or DOH header or SHTRVs. So the starting point is if the aggregate header limit of the downstream nodes can be obtained in advance. The risk of packet dropping or inefficient processing due to limit exceeding can be reduced. Next, please. The existing mechanism is in RFC 8883. So when a node discards a packet due to aggregate header limit exceeding, it should send an ICMPv6 destination unreachable error with code for headers too long. So with this mechanism, maybe you can choose to sending detection messages and receive the error message, so you can know what's the limit. And but it may work well when there's a large number of paths, because the burden of sending and receiving ICMP messages increases. And if the paths in SR, the paths may be dynamic, so the segment list may change over time. So it makes it more difficult to collect the limits in advance. And so we think IGP signaling may be a feasible solution. The first point is the head and intermediate node can easily get the aggregate header limits of all the nodes in the domain, regardless the amount or the type of the path. And the second point is there are already mechanisms like RGP MSD to advertise certain size limit at per node and per link basis. And next, please. So here's IGP extensions. Considering that MSD and the IGP MSD signaling mechanism is not SR specific, so we just define a new IGP MSD type value code for the aggregate header limit. And its value field represents the represents the total header size that the router is able to process. And it is defined mainly for protocol sympathy, but whether a new dedicated sub-TLV is better can be discussed further. Next, please. So here are some use cases if you get the advertised aggregate header limits. Mainly it's implementation specific, so we just provide some possible use cases. For the intermediate node, when it needs to increase the size of the packet header, so if we find that the downstream limits are exceeded, the node may choose not to use the related feature function and log an error. And for the head node, the first use case is similar. So when it needs to attach extra data along the existing path, it may choose not to use a related feature function and log an error. And the second use case is that it may choose to calculate the SRv6 path with awareness of the aggregate header limits of all the nodes within the domain. So for the controller, it can collect the aggregate header limits advanced by RGP or via BGPS for path computing and other management purpose. For example, whether to enable a certain function or the given path. I think that's all. Yeah. Thank you and welcome your feedback and comments.
Tony, you're first up in the queue.
Hi, Tony Lee, Juniper Networks. So first off, MSD is defined as maximum SID depth, and that's a really horrible name because, as you said, it's not supposed to be or should not have ever been about SR specific terms like SIDs. It should have been maximum label depth. But then you're abusing that by stretching it now to be a header length. So this really feels weird because we're confusing issues. This is not meant to be about the IPv6 header, and it's awkward. Second, The IGP is not a dump truck. Okay, this is not the place to be signaling this information.
Yeah. Yes, thank you. Uh, uh, if I get your point right, your first point, so you mean that we should not reuse the MSD signaling? Uh, we can we can consider the extension type. So it is because that it is, although it is a 0.0 version of the draft, it is a replacement of an original draft. And so we get some suggestion that maybe define dedicated subtier V is too complex. So why not use the existing MSD subtier Vs? But I think it is not the main point. And the second is because in SR, if this attribute is only for the head or the controller, so maybe so IGP extension is not that's necessary. But in this case, so in the intermediate nodes can also insert increase the total header size, no matter it is by SR, yeah. So maybe use IGP is a feasible way. So
Ketan,
Let's
please.
get Katan's comment in.
Hi, Ketan Talaulikar, Cisco. So thanks for your draft and the presentation. I understand what you are trying to do here, but I'm afraid the problem is quite more complicated. This is V6 IPv6 extension headers that we are dealing with, and depending on the header type and the role of the node, there are different headers, types of headers that the node would have to parse. So there is a hop by hop header which everybody has to pass. There is a routing header. There is other destination options before, later. I think this problem statement first perhaps you need to present in 6-man and get the problem statement defined a little more better there. There is also some 6-man work already, working group extension header limits. There is a draft. So I would suggest to kind of refine this problem in 6-man working group. And then I think down the line, we could look at whether it is even appropriate in IGPs or not.
okay, thank you. So maybe I send you the list. I already have some discussion in 6-man, but I didn't get the presentation chance, so I can send
Yeah,
it to
if
the
you
previous
have-
discussion.
You can forward the discussion to LSR mailing list. But by the way, we
Okay.
do have OSPF general transportation, and ISS as well for non-routing information population.
Okay.
Yeah.
Thank you.
Okay, shall I begin?
You should have control of the slides.
Okay, thank you.
Yeah, go ahead.
Hi. Hi everyone, this is Lian from China Mobile, and this draft is the topic about advertisement of remote interface ID for layer 2 bundle members, and I'm presenting on behalf of all the co-authors. The motivation of this draft is to help network operator to control bidirectional traffic flows on the individual members links of the L2 bundle for traffic engineering. And it leads to the requirement for the controller to figure out the connectivity relationships between the bundle members. And here we list the two typical scenarios. The first one is to measure the real-time bandwidth delay and link loss for each bundle member at both ends. And the second one is maybe we want to allocate labels and seed for each bundle members at both ends. As the figure shows, L2 bundle is deployed between the R1 and router 2, and the controller gets the technology information from our router 3 through the BGP-LS. To realize the socket scoped by directional traffic engineering, as the green chapters show. And what we want is that both the forward and the backward traffic are be carried on the same bundle links. So the controller must know the mapping relationship of the local member and the remote member. For example, here is the member 1 for router 1, and for the router 2, the matching number should be number 2. Here we intentionally mess up the matching relationships of the bundle members, just for better illustration, I think. And the solution of this draft is extending IGP to advertise this mapping relationship so that the controller can get the info from BGP-LS. And this is the solution overview. The main idea is to advertise the local and the remote interface ID for each L2 bundle member in IGP protocol. As the figure shows, according the advertisement from both sides. For example, from router 1, advertising the local ID for 101 and the remote ID for 202, and reversely, the router 2 advertising local 202 and the remote ID is 101. Through this advertisement, it will be easy to match the member link correspondence for the controller. Here are the extensions for the OSPF protocol. A new subtailway is defined in this draft, and we call it L2 bundle member interface remote identifier subtailway. And this subtailway applies to both OSPLv2 and OSPLv3, and is carried in the OSPF L2 bundle member attributes tailway, which is defined in RFC 9356. And the detailed format and position is shown as the right character and the falling arrows. And what I want to say is that since the current attributes TLV already contains the local interface ID, so the new subTLV only needs to contain the remote interface ID, just like the picture shows. And here is one note. Remote interface ID with value of 0 is not valid and must be ignored and handled as if the subTLV was not present. For ISIS, it's some kind of complex to encode L2 bundles because there is a limitation of 150 ops for every TLV. So in order to minimize the number of bytes, RFC 86 and 68 defines the shared attribute subTLVs, and these subTLVs can be shared by all bundle members. And based on this, so it is ISS can advertise a set of numbers in a single L2 bundle member attribute descriptor. So the new TLV must align with this, and it should carry multiple remote interface IDs, one for each of the bundle members advertised in the associated L2 bundle member descriptor. Also here, remote interface ID with the value of 0 must be ignored and handled as if the value was unknown. Accordingly, BPL's extension is also defined in this draft, and it can be carried as a sub-TLV of the BPL's L2 bundle member attributes TLV, and which is defined in RFC 90 and 85. And also, this TLV is optional, and the constraints are similar to the IGP definition. Last is about the acquirement of the remote interface ID. We also add one section in the draft to better explain the scope of the document. Because the layer 3 protocol is not operating directly on the bundle members. So IGP have no direct way to exchange L2 bundle member link IDs. So maybe some L2 protocols can be used to guide the remote interface ID for bundle members. Well, here we list the LLDP and the LIG bundle are both okay. And how the remote interface ID is obtained is out of the scope of this draft. Oh, that's all for this draft. Any questions or comments are welcome. And what I want to mention is that this is the second version of this draft. And after the author's revision, the draft has been changed. From the history, you can see, including the name, because the scope direction has been changed a little. And the content is much clearer than the previous version. And thanks all the co-authors for the work. That's all. Thank you.
Any questions? If not, okay, let's go to the next one then.
Okay, thank you.
Thank you.
I just had one. This was happened on the list, but you're going to add the other use case besides discovery by the controller, right?
Yes, we have discussed, and we will update it and submit soon.
Okay, thanks, Leanne.
Thank you, AC. Thank you.
Good afternoon, everyone. I'm Sandy Zhang from ZTE. This presentation is for the IGP extensions for TVR. And I present this draft on behalf of our co-author, and we have a new co-author, Jing Wang from China Mobile. And so next time,
Point to here. Point here. Not working? Yeah.
So let's see the background. This domain means that it's our IGP domain. In this domain, we know that there is a ground network with some nodes connected to the satellites. So we can call these nodes variable nodes. And there is another, some other nodes which is not connected to the satellites. We can call them non-variable node. So the variable node, because it connected to the satellites, so the metric may be changing schedually. So the variable node should advertise the information, the metric changing information to all the other nodes, and all the other nodes can calculate the routing table ahead of the scheduled time. And we know that because all of the changes is schedulable. So if we can calculate the routing table ahead of the scheduled time, we can make the packet loss or packet delivery converge time to the minimum time. And this is only one potential use case in TVR. And we know that in the TVR use case drops, there is many other use cases. So we know that in one IDP domain, there may be some other use case in in it. So how to use all the how to deploy all the scheduled time in the same IDP domain, that's what we want to solve. So this document helps the implementation of the intrinsic schedule defined in TVR requirements drafts, which has been adopted as working group documents in TVR working group. And the schedule based on flex algorithm, that's what we defined in this draft. We know that we think that it can solve the time overlap issues because we know that many use cases can be deployed in one IDP domain. So, and there may be some time overlap in it. So we think that we can use different FA to solve the overlap issue. So you borrowed the flex algorithm. The extensions can be generated by the variable node, just we said, the variable node itself, or the adjacent node, which when the variable node does not support IDP protocols. That's the other use cases described in TVR use case drops. The advertisement is flooded and can be received by all the other non-variable nodes. So all the nodes can calculate the routing table ahead of the scheduled time. And as we know that, when we advertise the scheduled time, we needn't advertise them periodically. And the calculation process is like a FAD procession. This is the specification. So we borrowed the FA defined in FC 9350, used for the scheduled time advertisement. The scheduled metric changing information, we treated the scheduled metric changing information as constraints. So we can calculate it like the other constraints defined in FC 9350. And we defined a new time variant subtil B, which is can be carried in EC's or OSPF fat subtil B to carry the scheduled metric changing information. And we defined a new metric type for the scheduled variant info because it's different from the existed IDP metric. And in the new version, we added the recurrence type, which is used to align with the Young model defined in TVR working group. So this draft was submitted as one TVR draft before. And now we think we can get more feedback in LSR working group now. So any comments welcome.
Tony.
Hi, Tony Lee, speaking as TVR co-chair. I want to just be very clear that this document is not a request from TVR.
So, as we discussed before, because in TVR, I think that the TVR YANG model can be used for other solutions. So, but we know that in one IGP domain, all the nodes may not connect to the controller. So, if some node cannot get the scheduled information, it cannot calculate the routing table ahead of the scheduled time. So we think that expect the controller dissension distribution mode, we can use some other method to deliver the information. So just is just one purpose. So if we in TVR working group, we know that all the working group agree that every node should connect to the controller and get the YANG model directly. So this draft is not useful. But if there is any other method needed for the information distribution, we think it maybe makes some sense. Yeah. That's my
Okay,
opinion.
so I'm the next speaking as a working group member. So first of all, I don't think it's necessary for all routers to know schedules of every single one router. So you don't need to do flooding for that. Second, you mentioned about multiple schedules and using flex algo to solve that issue. I don't get that point. Can you elaborate a little bit more? If you have overlap schedule, what does overlap schedule means here?
Yeah, because we know that there is many use cases in TBR use cases draft, and we know that if we deploy some several use cases in one IGP domain, such as one node or one link, the metric may be different, defined in different use cases. So how do we treat this model? In one schedule time, the metric is different for different use cases. How can we calculate it?
So in TVR, the use case we talk about, most of them are related with physical status.
Physical, okay.
Yeah, so we can talk more about this offline. Yeah,
Okay,
thank you.
Thank you.
Chris, you are next. One more. Hold on.
Yeah, I please understand that as this is speaking as a chair, co-chair. So Tony's comment carries a lot of weight here. You're bringing a TVR extensions draft, and then the TVR working group chair is saying that this is not support. You know, I mean, it doesn't. You're trying to do it. It looks like you're trying to do an end run, right? Like, because it's, you know, if I was just reading, it just seems like you're trying to ignore the advice of the TVR working group.
Yes,
It doesn't have good optics.
This draft has been presented in TBR working group last meeting, and we get the same feedback from Chair Tony Lee. We know that this has beyond the scope of TBR working group, and we know that if we want to define some other extensions for TBR, we should do the work in the associated working group. So we put this draft here to get more feedback. But as I said, if TBR working group decided that we can only use controller to distribute the YANG model for in TBR scenario, we cannot use this draft. But if there is any other way wants to distribute the information, not depends on the controller. So we think this draft may make some sense. So
Yeah. So
to
to that end, I mean, if I understand correctly, you're saying that this is a different distribution mechanism from Yang. That's kind of something I always go after is not putting things in the IGP, especially when they can be distributed in Yang. So as a working group member, not as the chair, but as a working group member, I mean, I don't support that at all. I think Yang is the right way to distribute this stuff, and we should avoid putting things like this inside the IGPs. Like as Tony said earlier in the meeting, IGPs are not a dump truck.
Okay, I see. But I have another opinion is that if the router must support the young extensions, so it's another story. And now we discussed here is that the router only wants to support the extension and it can't be only do by extensions. So we done it here. Yeah. It's just a different opinion. Yeah. Thanks.
Thank you.
I'm just going to say that maybe this should be discussed on the list rather than, you know, presented again or anything. You know, this whole concept of, you know, we're basically talking about the problem statement for distributing the schedule information and whether it should go into the IGP. I think there's, if you are going to accomplish what you were going to do with overlapping schedules and doing, you know, doing things ahead of time, make before break, it's a lot, you know, having these routing tables sitting, there's a lot more complexity that the draft doesn't even capture, but we haven't even agreed that we should do this. And I think that's the first step. And we have a number of opinions that we shouldn't put it into the routing protocol. And I mean, into the IGPs. So before we have any more encoding proposals, I think that should be discussed in TVR, and you could copy LSR as well. Thanks.
No. Go ahead.
This is Chang Wanlin from H3C Technology. I will behave my co-author to present the IGP card shortcut routine. First, we see the background of our draft. IGP shortcut as defined in 1396 enabled IGP to calculate route over T tunnels. IGP shortcut is based on nodes. If the first hop of a node is determined to be T during SPF calculation, and all route to the IP prefix at word highest by that node will be over that T tunnel. In some scenarios, there may be requirements to steer the router to different prefix of the same node onto different T tunnels. This document describes enhancement of IGP shortcut, which can steer routes over T tunnels based on colors. As the following scenarios between route 1 and route 3, there are two SR policies. SR policy 1 with a color of 100 corresponding low delay path. SR policy 2 with a color of 200 corresponding high bandwidth path. In case of traditional IGP shortcut, prefix 1, the next hop to prefix 1, prefix 2, prefix 3, and prefix 4 all point to SR policy 1. In case of color avoid shortcut, the next hop to prefix 1 and prefix 3 are towards the SR policy 1. And the next hop to prefix 2 and prefix 3 are towards the SR policy 2. The current solution based by policy-based shortcut on the head-end fielding policy can be configured. for tunnels used for IGP shortcut. Earlier, the prefix which specified the policy could be still over the associated T tunnel. However, the policy-based shortcut may create difficulty for operation and maintenance. Our proposed solution, first, colored IGP prefix. Second, the colored IGP prefix are still over colored matched T tunnels. For the scenarios just mentioned, we can assign a color of 100. We can assign a color of 100 to prefix 1 and prefix 3, and assign a color of 200 to prefix 2 and prefix 4. On the router 1, we performed the IGP shortcut calculation. Then we can select SR policy by color match. First, we see the IGP extension. We add a new color sub-TLVs for OSPF and ISS. The ISS color sub-TLV can be applied to TLV 27135, 235, and 236, and 237. And the OSPF color sub-TLV can be applied to OSPF extended prefix TLV and OSPF virtually intra-area and inter-area and external prefix TLV. Multiple color sub-TLVs can be attached to one prefix. We update the SPF calculation of IGP shortcuts as defined after 39.6. Add the following step when calculating next hop for prefix advertised by a node. If a prefix is colored, we look up the first hop information of the advertised node for T tunnels with the same color. If a prefix has no color, we use the next hop with lower pass cost. Maybe we can use the root tag to color the prefix, but there are two disadvantages. First, multiple root tag can be attached to one prefix. There must be a mechanism for the receivers to know which tag is used as a color. Second, the root tag is assigned for management, such as root policy filter. Finally, we give the possible use case for SR policy-based IGP colored shortcut. Between N1 and N2, BP exchange the service router, and IGP advertised BP's next hop router with color. The color the BP next hop router is advertised by IGP across the 3 different OSPF area. And each area performed the IGP shortcut calculation. Out of calculation, the BGP next hop router can be steered over the colored color matched SR policy. And then the BGP service router can rely on the IGP colored router. Finally, the traffic from E1 to E2 can direct the traffic over SR policy. That's all. Any questions, comments are welcome. Thank you.
AC, please go ahead.
Yeah, I was just gonna say that you really have a different The second use case is a really a different use case than is in your draft. This car stuff you introduced, I mean, to mix this in isn't really right because that's not part of the draft that you're presenting. And this is something that I don't think anybody wants to do.
It's just a possible use case.
You're saying you could use the same encoding, but you could also use, I'll just make, maybe somebody else is going to say this, but we already have tags for routes. You could use the tags for this without adding a new color for the prefix, I mean, for prefixes. Sorry. Anyway.
Tags. Tag.
Okay, I think Peter, I'll leave to get Peter
Take it
talk.
out offline. Yeah. Instead of
I
use tag.
Yes, thanks. I will respond in the mail list. Thank you.
Peter, go ahead, please.
Yeah, hi, it's Peter here from Cisco. So yeah, I have that comment. We already have the way to color the prefixes, which is tags. And the second point is how you select your SR policy tunnel or whatever you call it on the head end is a local matter. It doesn't need to be specified. So I don't see anything in this draft that we really need. We have existing mechanism to color the prefixes, and the local behavior of selecting a tunnel is something that has been available in multiple implementations already. So I don't really see anything new here, to be honest.
Okay, thank you.
Gian, please.
Hello, can you hear me?
Yes, please go ahead.
Yeah, so I was just going to mention the same. I think we have existing mechanisms with in BGP to color the VPN prefixes, and then which matches the SR policy color to map the VPN prefixes to the SR policy that needs to be instantiated. So I'm not sure what additional value carrying the color in the IGP, what that gives. Thank you.
Yes, thank you. Our aims is not, our solution is not related to BPCAR or BPCT. Our solution is just color the IGP prefix and select T tunnels based IGP color. It's just used in IGP shortcut scenarios. Thank you.
The IGP shortcut draft, I mean, I'm not, or RFC, I'm not familiar with that. How is that, is that building like a one hop, like a forwarding adjacency, like an RCPT type tunnel, or what is that doing, the IGP shortcut?
It's a very old draft, and it is like from the routing working group, and it is like a forwarding adjacency that you shortcut after you get done with your computation. You install the tunnel rather than the IGP next hop.
Gotcha. That's what I was thinking, similar to like an RSVP.
Offers were Hank Schmidt and Naming Shen.
Gotcha.
And it was routing working group.
Thanks, Ace.
Okay. Gian, do you have more comments? If not, we are going to the next one.
I know,
Yes.
that's it. Thank you.
Okay, thank you. Li Yan, please go ahead.
Thank you. I just want to reply the comments for previous people about the tag solution. Thank you very much for us to share this, and we want to read the tag solution carefully and discuss this in the mailing list later. Thank you very much. And about the question about why we do not use the BGP for the color distinguish, we think that we met this problem at first is in the central data center networks, and there is mostly appearing that there is no BGP protocol deployed, and just the IGP, and most IGP protocol is just the OSPF. And I'm not sure if this can clarify these concerns. Thank you. If any other concerns, I think we can discuss it through the mail list or the chat. Thank you very much.
Okay, thank you. If no more questions, we go to the next presentation.
Hello, everyone. I'm Yongqing Zhu from China Telecom. Today, my presentation is using Flex algorithm for LSR-based ARP. Let's take a brief overview of the background. ARP is introduced in RFC 9543. It is a collection of network resources located on set of links in the underlying network. An ARP can be used to support enhanced VPN or network services. Resource-aware LSR seeds represent subsets of resources allocated on network segments for packet processing. It can be used to build LSR-based ARPs with the required topology and the network resource attributes. In some network scenarios, the number of required ARP is relatively small. So each ARP can be associated with a unique flex algorithm for constraint path computation. This document proposes a mechanism to advise information of LSR-based ARPs using IGP flex algo and the IGP R2 bundle. Here, flex algo is used to specify the topology constraints of the ARP. IGP R2 bundle is used to specify the set of link resources and the attributes associated with the ARP. Let me explain the mechanism. There are two key points for this. The first one is how to advise the ARP topology attributes. Since each ARP is associated with a unique flex algo, then the flex algo ID can be used to identify an ARP in control plane. Thus, the topology of an ARP can be described using the associated flex algo. LSR amperes or LSR V6 resource-aware seeds associated with the flex algo can be used for ARP-specific traffic forwarding. The second one is how to advise ARP resource attributes. As we all know, the partition of link resources can be seen as a virtual or physical member links of a layer 3 link. IGP layer 2 bundle is used to advise the link resource-related attributes of ARPs. We use admin group color to correlate ARP with the bundle member links. And we use a new E flag in R2 bundle TRV to indicate the member links that are exclusively used for traffic of the corresponding ARP. We had a presentation in at IETF 112. In this presentation, we replaced the term VPN by ARP to align with the network slice framework and enhance the VPN framework documents. We clarify the scenarios where the proposed approach applies and refine the scalability considerations. Furthermore, we clarify the usage of the E flag. We think the content of the document is readable and would like to ask for work group adoption of this document. Any questions?
Les, please go ahead.
Yeah, so as you folks may have seen, Xi and I have had, I think, a very constructive conversation on the mailing list today. I'm not going to repeat those points here. I'd just like to make two comments. One is it's pretty clear that we don't have agreement on this, and therefore, and that there are significant issues that need to be discussed, not only in LSR, but also in Ts. And so I would ask that at a minimum, this draft be put on hold and not progress until we get some consensus on those issues. The second minor point that I would mention, which is, it's just something I didn't cover in the email thread, which is that the EBIT that you propose in the draft is completely unnecessary. I can explain why. If folks want, we can do that on the list. I think it's a misunderstanding about the way that the L2 bundle advertisements are structured, but that's a very minor point. Thanks.
Jay, please.
Yeah, just a quick reply to last comments. Yeah, firstly, I think we really appreciate the review and discussion about the document on the main list, even from different participants' perspective. Maybe they have different opinions on the technology. And actually, we see many people talking about using FlashArgo for NRP or network slicing. But clearly, the existing FlashArgo is just can cover a subset of the components or the functions, and we need some additional pieces are missing. So we are trying to build a complete solution based on FlashArgo. Regarding the E flag, I think that is maybe we can discuss whether it's needed or not. If we really don't need that, we can make it an informational document. That's even better. Thank you.
AC, you are the next. Yeah.
Yeah, I just had one. I was kind of following the discussion on the mailing list, and I don't understand why you would use different metric types for different NRPs. I mean, that didn't make any sense to me. It seemed like you just use different resource-aware SIDs, and that's all you need to use. I didn't see why there'd be lots of metric types. Or
yeah, let's Jiedong again. Thanks, AC. I think we didn't mention we need a different metric type for different NRPs. They can be reused. Yeah.
Oh, okay. That was just okay. I saw something about that being a scarce resource, and I thought, well, why would you even think about using that? Okay, it was just, it's not. You agree it's not needed.
Keaton.
Hi, Ketan Talaulikar, Cisco. So I understand that here, we want to have IGPs operate on layer 2 bundle members, right? To do some granular stuff. Now, the whole reason why bundles were implemented is that we don't have so many L3 interfaces, and IGPs and routing protocols don't have to operate on them individually. So my maybe naive question is, why do we use bundles at all when there is such a requirement? Just use them as L3 links, and the normal flex algo that we have today, you can use that as an RP. Why are we trying to, like, it seems like a kind of hack, right? So,
Jay, you want to
wouldn't
answer
that
that?
be simpler?
Yeah.
ahead.
Ketan, do you mean we can use a separated L3 link for each NRP? and each flash algo.
Yeah, just break the bundle, make them as separate
Yeah.
links, and then you can use. Then everything works as
Ye-
is. Nothing is required.
Yeah, that is an alternate solution, as I mentioned on the list, but that will bring the challenges when we discussing the introduction of the L2 bundle. Right, we make the more links
So,
in the
so the
L3 network.
yeah, but this is also not about. This is not just about flex algo, the default base algo, right? By keeping some bundle members excluded from exclusively used for a particular NRP, we are also changing the base IGP SPF. So again, I mean,
Yeah,
just don't use the bundle, and the problem is solved.
yeah. We think there's some scalability issue, but we can discuss offline.
I mean, I'm just going to jump in. I think what you're saying is you could still use bundles, just don't use different bundle members for different NRPs. You can use a bundle, but make it in just one NRP.
Maybe we can discuss on the list offline, but this is we just want each L2 bundle member link to be associated with an NRP, but all these NRPs, the control plane operate over this L3 interface, so we can reduce the control protocol overhead.
Les, you are the next.
Yeah, so I just want to reply a little bit to AC that the reason that the metric types came into the discussion was because I pointed out that the L3 route calculation couldn't be done accurately without being aware of the underlying L2 bundles, which we clearly don't want to happen. And so it G offered that, well, I could use a different metric type for every algorithm. And I was just pointing out that we don't have enough metric types to guarantee that that's going to work for as many algorithms as you might want to use. That's how that came into the discussion. It wasn't part of the original draft. So just a clarification.
Yeah, Jiedong again. What I said is we can use other metric types other than the IGP metric for flash algo, but we don't need to have per flash algo metric type, because if we don't rely on the bandwidth as a metric, the bandwidth, a specific bandwidth for each bundle member link, it will not impact the calculation in the IGP, right?
Well, okay, pardon me for jumping in, but that's not accurate. I think you have to look at the thread that you and I have had to fully understand that, and I'll defer that to the list.
I'm just trying to this volume low. I'm just trying to.
Les, do you have more comments? If not, we move to Gian.
No, I'm out of the list.
Okay, Gian, please. Hello? Gian, do you want to say something? Oh.
Yeah, sorry. Yeah, I just had just a quick comment. You know, on the I guess G on the bundle was the reason why I guess you're trying to instead of actually creating separate layer three interfaces, I guess, or link.
Jay, want to say?
Yeah, that is the reason we use L2 bundle to reduce the number of layer 3 links exposed to the IGP. Yeah.
I see. So like coloring, basically like one physical layer 3 link, like a big bundle with many member links, and then being able to have multiple colors on a single member link. I mean, on a single bundle, I guess. Is that the concept, I guess, that you're trying to achieve?
Yeah, I think, yeah, you're right. We need to have a per bundle member link, a color, and on the layer 3 link, it will be the union of all the colors of the members so that we can have
Colors
the
of the
flat cycle.
members. I see. So like individual member links could actually associate a different color for the individual member links.
Right, right. The color is used to correlate the control protocol, control plane, and the resource in the interface. Right.
Right. Understood.
Thanks.
So like the same concept of I think with like with SRMPLS, I think it is a little bit difficult to actually, let's say if you have one physical layer 3 link, you can't actually break out the NRPs. It may be a little bit more difficult, let's say, to do queuing. Like you can't do HQOS on MPLS, and if you want to do queuing, like it kind of have some differential queuing on the different let's say colors within a bundle. It may be difficult, but let's say with SRv6, I think if you have SRv6, let's say with microsid, I guess with where you end up having multiple a different locator per algo, you're able to match on an algo, so you can have like really discrete queuing characteristics, and so you could possibly carry multiple colors without doing anything else. You could do it with SRv6, but SRMPLS, it is definitely quite difficult. There isn't any way to do that, and that's like probably independent of having a member, having a bundle. It could be just a regular layer 3 link. You could actually have multiple link colors on a single physical link, but with SRMPLS, that isn't really possible of doing that. But now applying that same concept to what you're trying to do, I think if you're really trying to do the coloring, I see the point. If you have, let's say, a big fat pipe, but you don't want to have separate L3s, and you want to have a big fat pipe with many member links, but now you want to have different SLA characteristics per like NRP, different characteristics for each color. Then I could see that being a use case possibly of having a big bundle carrying like a high capacity bundle, but not wanting to have them to be separate layer 3 interfaces. So thank you. That was just my comment on that. Thanks.
Yes, thank you. We can continue discussion.
Okay, thank you everyone for the good discussion. Please continue on the list. So for this time, we did allocate a 15 minutes discussion buffer. I guess it served its purpose.
Thank you.
Thank you for the presentation. We'll go to the next one. I think we have one last.
Good afternoon, everyone. This is Jie Dong. I'm going to present this document, IGP Flash Algo with link loss, on behalf of the co-authors. Yeah. Okay, here are the contents of this presentation. We will give an introduction about the motivation and the solution. Then we will talk about the comments received and the discussion on the list. And then we will give the next steps about this document. Okay, the motivation is we know that link loss is an important performance metric that can directly impact the service performance. And it is necessary to avoid using links which have a high packet loss rate. The link loss rate can be advertised using existing IGP protocol extensions like the unidirectional link loss sub TLV defined in the existing FC for ISS and OSPF. And here it can be used for the
I'm not hearing anything.
I just had everything reset, but they're supposed to have been doing maintenance on my cable link, so I just assumed that was going on. But it looks like maybe it was a Meet Echo wide reset.
Yeah, I mean,
Yeah,
I can hear you. I can hear you guys, but I can't hear anything else.
Yeah. I also see that we are being transcribed.
Not
Oh,
not,
where
not
is
very
it?
useful.
I don't see it. But
No,
Is
classic
Yingson
network.
aware in the room?
Yeah, I don't know. No, but she's not responding, right?
maybe that we lost the room. That could be it.
Network partition.
Well, all right. The chat seems to be capturing it.
Oh yeah. Well, they should put the slide up that shows the one sentence change since the last presentation.
Yeah, yeah, they are saying they are working on it. Yeah, okay. Now it's better. I am able to communicate.
Okay, we got both audio and video from the room.
Okay, you can hear us now, right?
Yes.
Okay.
Do I need to repeat? Or where?
You, repeat whatever you think is necessary.
Okay, okay. So maybe we can
guess
briefly
you
repeat what I
start
just
from this,
said.
Just start from this page.
Okay, okay. So we know that the link loss rate is important metric. When for this already being heard?
Yeah, we've already heard this. You only had one sentence change in your document since your last presentation, right?
Go to the discussion point.
Yeah. So this is a brief introduction about the mechanism defined here. We use a new FAD metric constraint type, a constraint sub-TLV to specify the threshold of the link loss rate, so that when the link loss rate of a link is higher than this threshold, this link will be excluded from the calculation of the path. Okay. Here are the extension to FlatSago. This is a sub-TLV format, and is in the FAD TLV. Yeah. So here we can take a look at the comments and discussions on the list. First is where the source of this link loss information. Actually, we're seeing this for IGP, we already have this sub-TLV defined in the RFC 7471 and RFC 8570 to carry this unidirectional link loss rate in the IGP protocols. And for FlatSago, actually, the link loss rate should be carried in the sub-TLVs defined in RFC 9479 and the RFC 9492, because we are using this specific application-specific link attributes in the FlatSago. As for the measurement of the link loss rate, we can use existing IETF technologies such as TWAMP and STAMP. But for each specific operator, they can choose the measurement method. It depends on their policy or their available device equipments or the methods. Okay. And the second comment is about how can we surprise the frequent advertisement of the link status if the link loss rate change frequently. So we think there's there may be some cases the packet loss rate can change frequently around the threshold of this threshold value, so that we need to consider to introduce some timers in the device to control that, to delay the surprise, the advertisement of this kind of link loss rate change. Yeah. So for the next steps, I think we would like to thank the feedback from the working group, and it seems people think it's a reasonable solution, just we need some clarification. We have addressed all the comments received so far, and we will welcome further review and feedback and collaboration on this. In the end, we think since it's straightforward, we think we can ask for working group adoption if there's no further comments. Yeah. Comments?
AC, please go ahead. You are the first one. Hello. Can you hear us? AC, please go ahead.
I muted when I was unmuting.
Okay.
Just to switch it up. Yeah, I think the first time you presented this, people got hung up on how the link loss was calculated. And as you noted, we already have this metric in the IGPs as a TE metric, right? This link loss. Yeah. And it's been defined, and there was a lot of discussion then. And I think all that's needed maybe, yeah, I mean, this isn't necessarily for adoption, is some operational guidance. We had Ying Zhen and Chris and I had talked about this, that you'd want to use the same, the same mechanism across the domain when you're doing this for the flex algorithm.
Yeah.
For the link loss, have something, a similar method. You would want to do it one, but I mean, that seems kind of obvious, but probably the draft should say that. But I think, yeah, I don't, speaking as working group member, given the other constraints we have, I don't see why we wouldn't use link loss as a flex algorithm constraint as well.
Yeah, thanks for the comment. I think we will add some description about the as a guideline for operators.
Just add a clear statement.
Yeah, okay. In the next version. Okay.
Any more questions? Since this is the last presentation of this session. And you're done? Okay. If no more questions, I think we are done with all the presentations. Anybody want to say, since we still have 8 minutes left, anybody want to say anything? Gunther, please. Yeah, please.
Yeah, Gunther, routing AD. So this is going to be my first statement here, in the link state routing working group. So yeah, wonderful. So I just want to reiterate again what Tony Lee actually mentioned, is that the link state routing protocols are not like dump trucks for all sorts of information to put in there. It is really the underlay foundation for all communication. If it tumbles over, everything running on top of it tumbles over also. So that's a big drama. Now, what I'm seeing, for quite a while now already, we start to put more and more stuff into the link state databases, which is not always used for computing a best path through the network. We put a lot of, we start to put like lots of metadata, lots of other things and so on in there. And even though it could be like seen as a very easy like API for getting stuff across the network, it does come at a cost, because you have to send these things back and forward. You have to check the validation of that. You have to decode it, and you have to take care how to avoid duplicates and things like that. So that is probably going to be one of my focuses for the next 2 years, unless, and is to if there's like any other way of conveying some of the information, I would like to keep it out of the link state database itself. And if we still have to put it in there, there may be some valid reasons. Then I do want to be convinced that actually the IGP is the best way for doing that. So that is, something I would like to share with the working group here. So if you have any comments, please let me know. You know where to find me.
Okay, anybody? Okay, if not, I think we are done with this session. Thank you everybody for attending and the good discussions. And we'll see you in Vancouver.
Bye, everybody. See you in Vancouver.